In 2.5, we are multiplying using the distributive property. And the distributive property tells us that we can multiply a sum by a number or multiply the add-in. So if it was 15, we could do 10 plus 5. Multiply each of those by that same number, add those answers, and we'll get the same answer either way. So I'm going to show you a couple of examples that we can do using the distributive property. One example would be 3 times 13. So the first thing that we did was we actually drew out 3 times 13. Thinking back to 3rd grade when we learned multiplication, an array is when we would draw out 3 rows of 13 or 13 rows of 3. We're not going to do that because it's going to start taking us a long time. So first, to show the actual true representation, I'll do 3 down, 1, 2, 3, and I'll do 13 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now if I counted this just like an array, I would get the answer, and it would be, I could draw in dots if I really wanted to see that it's an array. So I'm doing 3 times 13. I can think of that just like a 3 by 2. Right? I'm going 1, 2, 3, 1, 2. Looks the same. Next thing I'm going to do, now I have this 3 by 13 array. Really difficult to be able to break it up and count them. I'm just going to end up counting 1, 2, 3, 4, 5, 6, 7, 8, keep going on and on. So one thing that we can do is we're going to break this up. I know that 13 I could break into 10 and 3. So I'm going to count over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have my 3. I didn't get rid of any boxes. I didn't add any boxes. I'm just making it easier for myself to see. Now I'm going to multiply because I know that with an array like this, I'm just doing 2 times 3. So over here, I'm going to do 3 times 10. That would get me 30. Here I'm going to do 3 times 3, and I get 9. This is where that distributive property, I've multiplied the add-ins, my 3 and my 10, by my number, and now I'm going to add them together. So I should get 30 plus 9 equals 39. Now I could do this another way if I did same thing, 1, 2, 3, go 13 across. Maybe I would prefer to do let's say 9 and 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I should have my 4. 3 times 9 is 27. 3 times 4 is 12. If I add these up, I'll still get the same number. So it doesn't matter how I break them up as long as I'm doing it correctly. Now what's going to happen, we talk about you don't always have graph paper available for you. And it can become really hard when we do 83 times 9, you don't want to still have to count over. So I know that this is what this represents using graph paper. What we started moving to was sort of what we called the cheaters array, where we're going to make it easy for ourselves. So I'm going to just draw a box or a rectangle. It's going to be pretty long and pretty skinny. And I just know that this represents what we did on the graph paper. So now I could do a problem like 5 times 18. So again, I just remember that, okay, this is what it represents. 18, I know I could divide it up into 10 and 8, so I'm not counting anything, I'm just going to break it up so I can see here's my bigger number, here's my smaller number. Then I'm going to multiply each part. So 5 times 10 is 50, 5 times 8 is 40. I add those up, 50 plus 40 equals 90. So again, we're going to use this to help us remember what we learned really in 3rd grade with arrays. This is sort of just the cheaters version now is what we call it.